Hello everybody and welcome back. Today it's time for another What's in the Box video. This arrived here last week while I was on vacation, and it came from Hong Kong. It says it contains toy parts. It's 3.8 kilograms and it got here through DHL Express, which was pretty cool because that went fast and it went through the tax office in no time, which is something that doesn't always work out. Yeah, let's have a look inside what it is. I think I know what it is, and it should be fun because it's gonna end up to be a comparison video to compare what I've been doing over the last couple of months and how this compares to what other people are doing. Oh, this is really well packed. And inside one box, we have another box. And this box does not have any markings at all. PLT Logistics. Let's move on. I know you can't see this, but this here has this certain Chinese technology smell that you get so often when you unpack something new. And maybe you can see this. This is a machine. This is a small machine. First of all, and whoa! It's made of 3D printed parts. Well, I wasn't expecting that. Let's see if we can get this further out. I don't want to break anything. It looks like it's taking quite a beating in here already. Here we go. This came out pretty nice. Now this is a very small CNC machine. And all of these parts here are 3D printed. Ha! Now how about that? I was under the impression that this would be aluminium. Very nice. This is the so-called A8 Mini CNC, and I thought I'd buy this one because it was reasonably cheap, and I wanted to do a comparison of what I have been doing over the past couple of months with what other people are doing, and I want to see if my projects compare, or if other projects compare for that end. And I thought I'd just buy this. It looks pretty neat. It really does. Nice stepper motors. The construction appears to be somewhat rigid and may need a bit of work. Looks cool. It has one of these Gerbil shields on the back of here with an Arduino Nano V3, and it calls itself the DIY 8000 Laser CNC 3.0. Apparently you can use this with a laser or with a motor for the CNC. Now, what else is in the box? There's a power supply. There's a set of cables. Here's the power brick. Some mounting accessories. A unknown power cable. And the power brick itself, which has interchangeable voltages. Very nice. 110 volts to 240, 1.5 amps max. Maximum output 24 volts, 4 amps maximum. Wow, that's quite a lot. Interchangeable plugs. And an open cable end. Let's have this. Also, we have a small piece of wood. And I guess that's it. And there's more. Another white package with another power brick. 12 volts, 5 amps. Well, I suppose one power brick is for the motor, and the other one is for the controller. And still more. White bubble wrap. Something heavy inside. What have we got here? We have a we've got the spindle motor. Nicely packed away. It looks like it's a 540 type, maybe even a little bit bigger, but I think 540s would fit as well. So this goes in here. Let's just leave this. And here we have what appears to be one engraver bit. Just one. It's not a lot. Alright. And that's it. That's what's in the box. No documentation. Nothing in writing. No drivers, no CD, no nothing, no manual. Well, it's a wonder that it made it through import. That motor appears to be pretty strong. There's no marking on it for voltage or amps rating. Too bad about that. It appears to have a 4mm drive shaft and bearings on both ends. That's nice. And it very neatly fits in here. Okay. That was the unboxing, so let's see if we can get this thing set up. Okay, now that we've unpacked the machine, let's have a look at the machine itself. This here was the offer. The machine is called the T8 DIY 3-axis CNC milling machine with Arduino and Gerbil. It's sold out now, before it was sold out, it was sold for 147 euros. I believe mine was a little bit cheaper than that. And apparently this is also available as a kit. I have been able to download the manual and all the information needed to get it working from the HobbyKing website. That is excellent as always. And looking at the machine, a few things popped in. Well, a few things are different than I expected. First of all, the tool holder here is 3D printed. The second part of the Z-axis is also 3D printed. The parts here are 3D printed, and they're not really fastened. The parts on the lower side here are 3D printed. That's not a problem. In fact, I like it that way, because if anything should break or if I want to modify anything, I could just 3D print my own and I know that it's going to work. The nuts for the axis are spring-loaded and they are backlash free, which is very nice. The steppers are standard NEMA 17 steppers that you would probably know from 3D printers or similar things. They have ball bearings, which is pretty cool. What I didn't like was mine actually has quite a lot of warping in the tool holder part. I don't think that's going to be a problem, but let's have a look. I noticed that the bearings that are pressed in here tend to pop out. This one here wasn't all the way in, but that shouldn't be a problem. If it comes back out, I will just use a little bit of glue to get it in. The table is pretty solid. The whole thing is very solid. It's a pretty good build. It's good quality, even given the fact that it has 3D printed parts and everything. It is still a very solid build. I quite like it. The motor here has a fan wheel, so it should be good for running for a long time without getting too hot. Because if it was getting too hot, we might run into a problem with the 3D printed parts here, and we don't want to have that. For my machine, the Z-axis stepper is not fastened down 100%. That might be intentional, but I'm going to check this out before I use it. And basically that's it. That is all there is to this machine. The frame is really heavy. The whole package was about 8 kilograms, and I would say about 5.5 to 6.5 kilograms is the machine alone. It's really neat. The controller board, I showed this before, is simple but efficient. I like it. It has 2 supply voltages for the stepper controller and for the spindle motor, and if you want to use a 12-volt spindle, you can operate that from the board too. It's very nice. You can use it either in a configuration where it drives the laser, a laser output, or a spindle output. If I read it correctly, if you use the laser output, it will even have PWM for the laser intensity. But I can't test that out, but it's a nice thing to have. Now, the next thing that I'm going to do is I'm going to get all the stepper motors wired up correctly, and I'm going to make sure that the whole thing works. I'm running into a problem with power bricks, because one of the power bricks only has a US plug, so I'll probably have to use a depth adapter. They're both rated for 240 volts, which we have here in Germany, but I don't really like using the adapter types, because that's just, it's not good. The second power supply is with the selectable voltage. I suppose that was meant for the spindle motor. Oh, I'm pretty sure it is. And that is going to make it possible to run the spindle at different speeds. Simple solution, very good. And that's about it. There's not much more to this little machine. It's really all there is. It's simple and effective. And by the way, this simple engraver insert, I had a look at it, and it looks quality. It really looks good. The diameter of 3.175 millimeters, I hadn't seen that before, so that was new to me. But the rest seems really, really good, and I want to get going, and I want to put it together, and I want to see it move. So, sit tight. Alright, for the sake of doing it right, I'm going to use only the tools that came with the CNC machine. I'm going to use only the cables that came with the CNC machine, and I'm going to be following the instructions as well as I can. So step one, there is a bag with a number of hex wrenches, which I find pretty cool. There are 5 in total, every size that you need. First of all, I'm going to tighten down the tool holder with the spindle motor in it. This should be pretty simple. Oh yeah, this tightens really nice. Okay, let's not overdo it. Then I'll attach the short length of cable that came with the kit, and there is a red marking on one of the connectors of the motor. Okay. There is some wire end protectors on here. I'm going to use those too. Install the negative. And that's it. Connection is done. Next I'm going to untangle the Z-axis stepper, the wires, and there is some, let's open this up, there's some wire wrapping material here, very nice too, that you can use to join up the wiring here. And let's use just a bit of it for a start. So the kit is pretty complete. There's nothing that I think is missing. It's really, they made quite an effort to make sure that you get everything you need. And that all the tools that you need are included. And there are even some, well, leftovers, I think. For example, there's a number of connectors for the power supply that they used, and since we're not going to be using them, you can just keep them. They're pretty nice. There is a little brush to clean off shavings, things like that. It's also very nice. It just makes it feel like a pretty complete package. And I, for one, I like that. So, this is kind of a cosmetic thing, but I like to do these things right at the beginning, because if I don't do them at the beginning, I'm never going to do them, and it's gonna be early looking forever. And so let's just do it right at the beginning, and after that looks good. It's all clean. So while I'm drilling this up, I did some research on the controller board, and the controller board is used in quite a number of appliances that are available. For example, laser engravers, simple plotters. All of these things, they all use the same controller board, and I didn't find a lot of documentation about how to set it up to use it with other software, but I guess that shouldn't be a problem to find. Okay, so I've done this stepper. Now the cable here is all wrapped up in one nice package. I'm leaving it at this length. I'm going to cut this off later. I'll continue with the X-axis stepper. I don't know if the cable appears to be rather long. I'm probably gonna wrap that up one way or the other, and I'll finish with the Y-axis stepper. And I'm going to wrap that one up too, so it looks really neat and clean. When I got this first, I was under the impression that this would be a kit. It's not, and that is pretty cool. Now, the documentation states, where is it? That this here is the X-axis, these two are the Y-axis, and this here is the Z-axis. So we're going to start with the X-axis. And continue with the Y-axis. By the way, there are marked, there are little markings on here. Very nice. And yeah, I kind of overdid it with the wrapping, so I'm just going to remove this here. And unwrap it a bit. Oh well, maybe not. Nope, didn't overdo it. But looking at it this way, this should be. Oh, this cable must be mounted through the middle and not through the start, because the wire for the motor is a bit short. Wow. Why is that? So we need to remove the clear cover from the controller PCB. And we need to screw in the motor output. The spindle output is on the left side and the supply in is on the right side. There are no markings for polarity that I can see, and but there wouldn't be, because this is just a simple relay. I expect that they're just switching one input to the other in the same direction that they come in. So the documentation says that we're supposed to keep the red wire on the right, and we'll put that one here. Check, yep. That is good. And the Z-axis stepper is going to go right here, but we might pass it all the way around so we can just tie all these stepper cables up in one place. That may make it look nicer. Not that it's needed. And if we do that, we can keep on wrapping this. Just cut it. So this should look pretty clean. Now, for the connection of the spindle power supply, I'm gonna do that right now as well. We put the red cable to the right and the white cable to the left. Okay, that's it. Now, let's take all this loose wire. See where we can put this. I suppose down here would be okay. Right. I realize that if this doesn't work the first time around, I'm probably gonna have to put this all away again, but all of this looks so nice and clean and thought through that I guess it's okay to tighten this down like this. I'm using a cable tie to put all the excess wire in one spot, and I'm going to use a little bit more of that cable wrap to go up here. This will make it look nice and professional. So all in all, the value that you're getting for this machine is pretty good. I had a look and I paid about 135 euros for this. The price now is about 140 something. It costs about 40 euros shipping to Germany, so that comes on top of that, and I'm pretty sure that the handling fees for importing this were about 50 euros too. So all in all, that's not too bad. You do get the controller board, you get the aluminium frame, you get the steppers, you get the spindle motor, you get the spindle, the engraver, and everything is all set up basically to use. So I say it's a pretty good deal. And of course that slipped out. Yeah, that's what happens. Okay, let's put all of this back in here. Make sure that all the wires are close together. Oh, something went wrong here, but it looks, I guess it looks okay. All right, we got power attached. We have the steppers connected. We have this here says it's in the laser mode, so I'm going to take this little jumper and put it over the pins for spindle mode. And this is all pretty well set up, I would say. So next thing around, I'll just put this down, and let's check for all of these here. That they're, yeah, that is not tightened down right. I'm assuming that they don't tighten these screws all the way when this thing is getting transported, because if it that way it still has a little bit of flex in the frame, and it wouldn't break the 3D printed pieces. It's kind of nice. I'm going to put the back cover back on again, because I think I'm done here. And if I'm not, yeah. Alright, that does not go on this way, but that way. Well, when I'm done, I'm going to use another cable tie to tie this cable to the bottom of the controller board. I'm using one of those wrap wires for that now, just to make sure that there's no interference between this wire and the table, whatever's on the table. So here we go. All right, all set up and ready to go. Well, ready to try. And by the way, I like the foam inserts that came with the machine, because to minimize vibrations and to keep everything nice and quiet, I usually put them on one of those foam boards, and so that they came with the package. That's just a bonus. Now, all of this looks really cool. The machine is all set up, motor connected, steppers connected. I'm not going to put a tool in yet, and maybe it's time to get some sort of computer set up and try if we can use it. That's where we'll continue. Alright, I went ahead and I did all the setup with the PC. I plugged in the power supply and made sure that everything has power. I took the power supply for the spindle motor and put it on its lowest setting, and I installed girdle control. I used the slightly older version, but that shouldn't make any difference. And it's time to hit connect. So if I connect the CNC to the laptop, I can see the initialization sequence. It appears to be working. All the settings look okay. And let's see if we can get it to move. Since this is Gerbil, we need to actually do the first move manually. This isn't an issue later on, but if you start something up for the first time, you should set the speed for the axis movement, because that is not that doesn't have a preset. On some machines it does, on others it doesn't. I'm assuming it doesn't on this one, so we'll just type G1 X0 F 200, and that tells it to go to 0, where it should already be, and to do it with a speed of 200 millimeters per minute. And apparently that worked. Now after we've done that, we can use these arrows for movement, and that should work. Yep, it's definitely moving. The table is moving too, which is pretty cool. So does the tool head, and we can make the x-axis move too. Yes, very nice. And we can check if the spindle will start, so I'll just click on spindle on, and nothing is happening. But there's a reason that nothing is happening, because with a setup like this, the spindle speed must actually be set to the maximum, and probably that's not the case. So for the first time I'm going to manually type the command M03 S10000. That should be speedy enough. And here we go! I can now click the spindle on and off button twice until it's off again, and it works. Okay, just for the heck of it, I preloaded on engraving, and we're just going to see if I can issue the, if I can make it if I can make it engrave. I'm gonna put it somewhere safe, then I'll click 0 position to set this position to 0. I'll load my file. Here we go. And I'll click begin. Let's see what happens. Apparently it's working. I didn't expect anything else, but it's nice to see that it does. I am going to stop this right away, which is going to take some time, because Gerbil has some sort of, well, a sort of caching mechanism, so it'll store a number of commands in the controller before actually stopping the print. I could stop that right now by just clicking reset or pulling the USB, which I'm going to do now. So that was a very quick test. I haven't checked if the table setup for the x-axis is completely parallel to the table. I'm still going to do that. But apart from this, this was a very simple setup. It was really easy to do. And although it's a small machine and it's all very simple and the 3D printed parts, this went really well. I'm quite impressed, actually. No showstoppers, no problems, nothing. This is really interesting. So let's come to a conclusion about this little CNC machine and what I think of it. I did like that it came assembled. I liked that everything that I needed to get it to work was part of the package, starting with the tools, starting with the power supplies. The main power supply for the Gerbil shield didn't come with a EU plug, which I suppose is okay, but it didn't have a detachable power cord, so I'm probably not going to use it, but that's alright. I liked the speed, I liked the power. I didn't have any issues setting up the software or getting the shield to run. I did spend some time leveling the table and the x-axis assembly. I liked the motor, which by the way is a 775 24 volts motor. I was reasonably happy with the engraving tool that was supplied, which is a it's a 0.1 millimeter 30 degrees tip, although it was labeled 0.2 millimeters, but to me it's more like a 0.1 millimeter tip. I like the way the software worked. I like the way the table worked. I was able to do some tests, and I'll just show these. I did some PCB extrusion milling. Let's see if I can focus on that. And that looks really good. This is just an old PCB. I'm not going to use it. It's just some of the junk that I had lying around. And it really compares to what I've been doing with the laser. And apart from the fact that doing a whole board with the extrusion milling would take quite a long time, the quality is very good. The X and Y axis repeat and return is really almost optimal. Even small lines trace very well. I was very impressed with that. The noise level is a lot better than I expected. This isn't very loud. It's not so you want to put it in your living room or close to a children's room, but for a work area where you're alone, that is not a problem. I'm probably not going to do a lot more extrusion milling with this because I'm not a fan of doing copper PCB extrusion milling, because the small shavings from the PCB, they may contain glass fiber, and the shavings from the copper, well, of course, contain copper, and copper is poisonous, so you have to be really clean about it, and you have to don't do it where you're living, do it in a workroom, be clean, all those things. Copper is dangerous. But somebody might argue doing laser extrusion is dangerous too. So yeah, that's true. So what else do I like about this machine? Basically everything. The only thing that I am going to change is I'm going to take the Z-axis apart again because one of the screws came loose, and I'm going to put it together using some Loctite glue on those screws, and I'm going to add some smoothing capacitors to the motor, because I had the issue that while the motor was very new, I would actually have the gerbil shield crashing on me, and I'm pretty sure that that is due to interference caused by the motor, because the cable is going very closely to the stepper cable, and everything is really close to each other. And I'm just going to add a smoothing capacitor to the case of the motor and across the power leads. In the future I may have more about this machine. I did have to order extra CNC milling bits and engraver bits, because the ones that I have are not 3.175 millimeters, which is okay too, because they're reasonably cheap. So in the end, this was a very nice excursion into CNC machines. It compares very well with the one that I built myself, although that one is only used for doing CNC jobs or doing plotting with a pen, or extrusion, or lasering. Simpler works than that. This is really sturdy. This has a lot of force, and you can do a lot of things with that you couldn't do with my machine. But it's also a very good example of how you can get away with having a moderately pricey assembly made from aluminium together with 3D printed parts. So that's maybe one of the reasons why I like it so much. And in the end, this is a pretty good package. I realize that this is not the original. The original T8 CNC machine is made from aluminium all the way around, so this might just be a copy. I'm not sure about that, or if it's just a cheaper version. But apart from that, solid machine, good to work with, easy to set up, came completely assembled, and sent off from HobbyKing, arrived within 5 days through DHL Express, and a nice machine. Kudos to HobbyKing for handling once again. By the way, this is not by HobbyKing, this is not a review sample. I bought this myself. That was one of my ideas. So, cool machine, easy to set up, usable with open source software, so I like it. It's not a 10 out of 10, but it's at least an 8 out of 10, maybe even a 9. Thank you for watching, and bye bye.